Hi, welcome to the video for question 18 and question 19. So for question 18, it reads, for each of the following families on the periodic table, list how many valence electrons they have and what you know of their properties. Well, the first one's alkali metals. And really what it's asking you to do is, do you know the names of the groups? So, alkali metals are here, except for hydrogen. We have lithium, sodium, potassium, rubidium, cesium, and francium. And these metals, if you recall, will explode. We saw videos on this. The metals explode when they touch water. And I'm still waiting for a dry day to do this demo with you guys. I like having fingers, and that's always an issue. Then it asks for alkali earth metals. Alkali earth metals are here, from beryllium, magnesium, calcium, so on. Now these guys are less reactive than the alkali metals, still very reactive. And if we see right here at the top, we can see that there are two, how many? Two, that is correct, two valence electrons. Well, this one has one. How many? One valence electron. And that's also true from the previous video that we made and the previous question that asks what is their ending configuration. So this would be it would be S1, this would be S2. That would denote how many valence electrons we have. Now remember that the transition metals are odd and there can be several different versions of them. And let's skip all the way to halogens. Halogens have 7 valence electrons. And these atoms would do anything for an extra electron. They just need one more, man. They just need one more to reach noble gas configuration. So these are highly reactive, highly reactive atoms. There's 7 valence electrons. They need one more to reach 8. Now when they do reach 8, they would become noble gases. And noble gases have 8 valence electrons on their outermost shell, fulfilling the octet rule that states that most atoms want to have 8 valence electrons on their outermost shell so that they can achieve stability. Now these are not very reactive, and they're actually the more stable of the period. So if it asks for the most stable ones, you might want to look here, just like on the test we had, right? Okay, that's question 18. Let's look at question 19. Explain the group and period trends in the periodic table for the following. So atomic radius, we talked about this. Atomic radius is how big is the radius of your atom. Well, as for group trend, so it's and period trend, so it wants to talk about them going down and them going across. So if you recall, the radius gets smaller as you go towards fluorine, and it gets bigger as you go towards francium. So the larger radii are here, and the smaller radii are here. You guys are pretty well on that. Ionization energy. Ionization energy, if you're in a group, it decreases. What is ionization energy? Ionization energy is the energy required to remove one electron from an atom. So if you recall my analogy, here are the bad mothers. And the bad mothers don't very much take care of their electrons, so you could steal one and no one would notice, as opposed to on this side, when they take care of their electrons and they're very protective, and it would take a lot of energy to take an electron away from here versus an electron away from here. Also remember that you can only take so many electrons before the atom starts noticing, so the more electrons you take, the more difficult it becomes to take electrons. Electronegativity. Well, electronegativity will go down as it will decrease as you go down a group, and it'll increase as you go across a period. So, just like the ionization energy here is low, low, so is their electronegativity. So here we have the highest ionization energy and the highest electronegativity because they want to keep their electrons. And cesium has the lowest electronegativity because it's very easy it doesn't take care of its electrons very much. There we go. Alright. And ionic radius. Now, I like to think of electrons as pounds on me. If I lose pounds, I become smaller. So if I were fluorine needs just one more electron, but once it gets it, it's going to get bigger. So an anion gets bigger when it gains an electron, as opposed to lithium. Lithium will lose an electron when it becomes a cation, therefore making it smaller. So the cation of lithium is smaller than the atom of lithium, as opposed to fluorine, which is smaller as an atom but larger as an anion.